Thank you very much, first of all, for the kind introduction, and thank you particularly to Professor Steve and Dr. Anjali for the kind invitation to speak on the topic of what I've called heterogeneity of healthy aging. These are my disclosures. So across the world, we're seeing major shifts in terms of population aging, and key facts, and these come from the UN. First of all, the pace of population aging across the world is much faster than it was in the past. And between 2015 and 2050, it is expected that the proportion of the world's population over 60 will nearly double from 12 to 22%, which is quite a lot of people. Of note, in 2050, it is expected that 80% of older people will be living in low and middle income countries, and thus all countries face major challenges to ensure that their health and social systems are ready to make the most of this amazing demographic shift. And of course, there is differences in countries across the world, but this is the general tendency. So looking at people with HIV, and you've seen this slide a couple of times already before in previous talks, as a result of the success of ART rollout, people with HIV across the globe are aging as well. And this slide shows the proportion of people over 50 in different parts of the world. And because of the earlier access of ART in the Northern Hemisphere, you see that that proportion is larger. However, in terms of absolute numbers, simply because of the nature of the epidemic and the spread across the world, the absolute number of people with HIV 50 years and older is much greater in low and middle income countries. So, growing older, unfortunately, there's the difference between lifespan and health span. So, increased longevity doesn't necessarily mean that you remain free of disease. And health span, the term health span is used to refer to the period of life free from chronic diseases and disability, and is characterized by optimal physical, mental, and social well-being, something that I would say every one of us strives for. So health span doesn't emphasize just lifespan, but also the quality of life during those years lived. We also know, however, that aging is by far the largest and the strongest risk factor for the risk of developing non-communicable comorbidities. And I won't go into details, but those of you who are clinicians, many of those are shown in this slide. And I do want to stress that these include both physical as well as mental health issues. So that being true, this is no different in the population of people living with HIV. This slide comes from our Dutch national HIV cohort that has been ongoing for many, many years. And what you see here is the number of comorbidities next to their HIV that people have in relation to their calendar age. And as you can see, if you look at the right-hand side of the graph, those over 60 and particularly those over 70 clearly show increasing multimorbidity, so suffering from two or more comorbidities next to their HIV. However, in the context of HIV, compared to in this case, a cohort study that we're running in Amsterdam, also together with Professor Maarten Schim van der Loof, who you heard speak earlier in the conference, where we are able to compare people with HIV to a very highly comparable group without HIV. You can see, if you concentrate on the left-hand side of this slide, you can see that the mean number of comorbidities developed per year is consistently higher in those with HIV, which is the red line, compared to those without HIV, which is the blue line. And this increased burden also is associated with an increased risk of mortality, so it's actually meaningful. Now, if you look at the right-hand side of this slide, we looked at the causes of death in this cohort over time, and what was striking is the clearly increased rate of development of non-AIDS malignancies and the chance of dying of these malignancies in those with HIV. So in this population of people with HIV who've been having HIV for many, many years, who've been suppressed on ART for a long, long time, the striking thing is the propensity to develop and die of non-AIDS malignancies. And I think this is something that is going to be seen elsewhere and is being seen elsewhere, needs a lot of attention. So these are particular comorbidities. However, if you speak to people who work in the geriatric field, the other thing is important are so-called geriatric syndromes. Conditions which don't fit into discrete disease categories, who have multifactorial etiologies and involve multiple organ systems. And as you can see listed at the top, I won't go through them all, but listed at the top you see frailty, something that Professor Erlandson discussed yesterday. And also, if you remember one of her slides, she put frailty also at the center of our thinking about aging. So what about the frequency of these geriatric syndromes in people with HIV? Well, this is a study which is about 10 years old now. It's a cohort study, the SCOPE cohort from San Francisco. And you see that these so-called geriatric syndromes are actually very frequent. I'm not sure whether they've ever followed up, but this was one of the very first studies in HIV looking at these geriatric syndromes, and I think this is something, and including in our own study, that will need increasing attention as our cohorts that we follow get increasingly older. So back to the determinants of human health span. It's important to realize that human health span is influenced by a complex interplay of interconnected factors. And these include biological factors, but they also include a lot of other factors like lifestyle choices, the amount of exercise you do, how you sleep, how you eat, how you manage stress. Environmental factors are important, and also other factors like socioeconomic status, access to healthcare, inequities and inequalities, and also social support systems. For the latter, think of something like loneliness, for which I understand the geriatric field is thinking of using loneliness as one of these geriatric syndromes I talked about before. So I've highlighted here biology, and I want to spend some time talking about the biology. So when you dive into the biology of aging, the field that studies that have defined 12 hallmarks of biological aging, which are depicted in this circle. And there is a recent review, which is actually, I think, quoted at the bottom of the slide. If you dive into the literature and look for information to the extent by which HIV or certain antiretrovirals affect each of these 12 biological hallmarks, you actually can find literature which suggests that that's the case. You do need to realize, however, that much of that literature concerns in vitro studies or ex vivo studies, so not all of this comes from human data. There is one, I think it's listed on the bottom at about, 7 o'clock, mitochondrial dysfunction. Of course, if you remember the toxic nucleosides that we used in the past, there's very clear clinical evidence in HIV that has implications, and mitochondrial dysfunction is one of these hallmarks. The other one that I've encircled with the red circle is chronic inflammation. So chronic inflammation is one of these hallmarks of aging. So aside from HIV, is important in aging. Another one is epigenetic alterations. Epigenetic alterations occur with aging, and there are many epigenetic markers which are considered very good markers of biological age. So what do we know about epigenetics? So I'm using this study as an illustration. This is a study from Switzerland that I was happy to be involved with. It's conducted within the well-known Swiss HIV cohort study, and what they've been able to do is measure one of these epigenetic markers of biological aging over time, both to the left of the zero in the graph before people started ART, and then to the right of the zero after people started ART and became virally suppressed. And what they found, if you look to the left of the zero, is they found evidence of epigenetic age acceleration in the absence of ART, so the natural course of HIV infection. And then on average, after ART was started, there was a deceleration in epigenetic aging. So a good sign. What the study, of course, lacking a control group, cannot say is whether the decline in epigenetic aging actually went back to what you would have expected in the absence of HIV. Another example from these hallmarks is dysbiosis. And we generated some evidence from our own study in Amsterdam and found that the gut microbiota differs in people with HIV regardless of sex and sexual practice. On the left side of the slide, you actually see that the microbiota signature associated with HIV was really opposite of the signature associated with men practicing sex with other men, which was interesting. On the right-hand side of the slide, what we found is that this signature associated with HIV actually was correlated to a systemic marker of inflammation. So dysbiosis linked to inflammation. And it was also associated with the prevalence of comorbidities. This was a cross-sectional study, but we did a follow-up study in which we found evidence that actually these changes in microbiota signature preceded the onset of comorbidities, suggesting that there may be a causal relation and that this may be one of the pathways by which the risk of comorbidities is increased. So I told you already that one of these 12 hallmarks is chronic inflammation per se. However, if you dive into that literature, it's interesting to see that each of the 11 other hallmarks in one way or another also promote inflammation. So inflammation, depicted here visually by the fire, is really reinforced by all these biological processes that are underlying biological aging. And of course, we know that HIV in itself is an inflammatory condition. So inflammation is promoted both by HIV, speculative by certain antiretrovirals, and by aging, and it also may be reinforced by derangements in each of the other 11 hallmarks of aging. And I think this is one of the reasons why inflammation is something which is getting a lot of attention in research in HIV and aging. So back to the title of my talk, Heterogeneity of Aging. We actually know, and you can see that, of course, when you are with family or with friends, we don't all age in the same way. And what do we know about that difference from general population studies? So this is a very interesting study from New Zealand that I came across. It's called the Dunedin study, called after the city, I think, in New Zealand where it was started. It's a population representative cohort study, a birth cohort study, which was started in 1972-73, enrolled over 1,000 individuals, all born in that same period, and they were followed from birth to age 45, which they reached in 2019, and they had remarkably high retention rate of 94% in this cohort. So what they did is they quantified what they called participants' pace of aging by tracking shared declining function in 19 biomarkers related to the cardiovascular, metabolic, renal, immune, dental, and pulmonary symptoms across different ages. So at age 26, 32, 38, and 45, they did the assessments of these, let's say, called organ functions, and that's schematically depicted on the right-hand side of this slide. If you concentrate on the left, they use linear mixed effects modeling to quantify each participant's personal rate of change across each of these 19 biomarkers, and that led to each individual's pace of aging. And on the right, you see the frequency distribution of that pace of aging for the cohort. And the red arrow shows an example of somebody who has a pace of aging which is twice as fast as the cohort average. And if you go, of course, to the left-hand side of the curve, there's also people who age less quickly than the average. So I'm showing this because it's from a general population study, really well conducted, and it shows this heterogeneity in aging. In that same study, They also, for instance, this is just an example, there are numerous examples in the papers from this study, participants who aged faster between age 26 and 45 by external assessors of photographs were perceived as looking older by independent raters. In addition, those aging faster had more cognitive difficulties, signs of advanced brain aging on imaging, diminished sensory motor function, and also more pessimistic perceptions of aging. In this study, they also did epigenetics. I already explained to you that epigenetic markers are considered good and important markers of biological aging, and they derived a so-called Dunedin pace of aging methylation marker, which correlated well with the pace of aging that I showed you on the previous slide. And they also validated this analysis in several studies, and it provided proof of principle that if you use this epigenetic marker at a single time point, you could get a reflection of a person's biological aging, pace of biological aging. So that's the general population. So what about heterogeneity of aging in people with HIV? What do we know so far? And I'm going to give you some examples, and this is really early days. This is a field which is developing and needs to develop further, and there's still a lot of questions. So I'm going to show you a little bit about heterogeneity of epigenetic aging, and also, as I told you, inflammation is at the core, heterogeneity of systemic inflammation and immune activation. So this is the slide from the study I showed you previously, the study from Switzerland. And interestingly enough, concentrate on the red arrows that I've pointed in the graph. This was actually pointed out by one of the reviewers of the paper who said, well, the average is fine, but what about the difference between individuals? And the red arrows show individuals who, for instance, the top two arrows show individuals who, despite going on to ART and being virally suppressed, actually show a continued increase in epigenetic aging. So this was actually a very good observation of the reviewer, and we reflected that in the paper, but to me it also shows that in this population you have heterogeneity in epigenetic aging. And what that means clinically is something that hasn't been studied yet, and this sample is simply too small. But if you were to do, for instance, epigenetic markers in the whole Swiss HIV cohort study, you could actually get a handle of that. Inflammation, heterogeneity in inflammation. The group of Paddy Mellon in Dublin was really one of the first to start and look at this. And what they did is they measured lots of immune and inflammatory biomarkers in a subset of the POPI cohort. The POPI cohort is an aging cohort which runs in the UK. And they used 31 biomarkers in this case, and that's important to mention. These are all soluble biomarkers measured in serum. And using a statistical technique, they identified within this cohort 3 distinct inflammatory clusters. And 2 of those, depicted by Roman 2 and 3 on the left-hand side of the slide, are associated with increased cardiovascular risk. So what's the bottom line of this study? That here you have a population of people who have all been on ART for extensive periods of time, who are all virally suppressed, who have all reasonable immune restoration, but if you dive deeper, you can distinguish patterns. And it could be, this is our associations of course, that these are relevant with respect to the risk of developing comorbid disease. Using that example and having access to an extensive biomarker data set from our own aging cohort study in Amsterdam, we did a similar analysis using a different statistical approach. And we also, in our cohort of people with HIV, and in fact also in the ones without HIV, identified 3 distinct profiles. In our case, we also had access to cellular markers, including markers of thymic function measured by TREX and recent thymic immigrants. And intriguingly enough, and that's the boxes that are highlighted on the left, one of these patterns was characterized by markers of high thymic output and low inflammation. And why was that important? Because we correlated that to the risk of incident comorbidity development, and we found that these people who were characterized by having sustained thymic output and low inflammation had a lower risk of developing a composite of comorbidities. The study was too small to look at individual comorbidities, but the composite of cardiovascular disease, diabetes, non-AIDS malignancies, osteoporosis, and frailty was associated with a low risk. So these people, if you see them in the clinic, they all have suppressed RNA, they all have good CD4 cells, they've all been on treatment for a long, long time, but they're different. So heterogeneity. So this is a small study. This needs to be repeated in a larger group. The other thing, of course, if you think of, these are complex biomarkers to measure. So the next step would be, well, could we derive a simpler composite or a simpler marker which theoretically might be available in the clinic? And the one thing you need to know is, are these patterns sustained over time? So one of the things that one of our students, Manon van Bellegem, is going to look at is whether the distribution of these patterns in the cohort actually stays over time, because if it fluctuates all the time, it's never going to be a clinically relevant measure. So that's something we need to know. So back to the determinants of human health span. Very important. It's more than just biology. The biology is really interesting. The biology is important, but these factors are interconnected, and I want to stress the importance of the social determinants of health listed at the bottom. And we need to realize that if you put that in the context of HIV, that HIV actually may influence each of these. I reviewed the evidence for the biological factors, but as we all well know, the social determinants of health, many of these are also affected by HIV. So the impact of social determinants, I've just put this in. This is not necessarily about aging, but this is again for our Dutch HIV cohort. And very recently, the cohort has been able to link their data on this representative population of people with HIV in the Netherlands to data from our so-called Central Bureau of Statistics and get a handle on how and enrich their data with social determinants of health. And you find, for instance, that if you've compared the Dutch population with HIV to the general Dutch population, the likelihood of them being young is much smaller. So we have this relatively aging population with HIV, and they're relatively much more likely to have low income. And this is linking those data to the cascade of care. And if you concentrate on the yellow bars represent the proportion that are virally suppressed, and you'll see that younger age is associated with lower likelihood of being suppressed, but also lower income is associated with a clearly lower likelihood of being virally suppressed. So just as an example, that having access to these data may actually lead to fine-tuning of how you interpret your data and to identifying subgroups of people who may need particular attention and are at risk of worse HIV outcomes. So to summarize, people age differently. I hope I've convinced you that people age differently, that aging involves multiple biological and non-biological factors, that many of these may be affected by living with HIV, and that this thinking needs to be reflected in our research designs, if at all possible, and also about ways to promote healthy aging. I'd like to acknowledge, of course, first of all the participants in studies of aging with HIV, not just in Amsterdam, but across the world, my own research team, collaborating researchers, and funders without whom none of this research would be possible. And I'd also like to end that maybe the way that the HIV field is studying aging in the context of chronic inflammatory conditions. One of my hopes is that it will also generate information and evidence which is helpful for studying aging in general. So with that, I'll end and take any questions.